let's begin by looking at the reduction reaction of aldehydes and ketones. Now, let's do a couple of examples here. Let's say we have the aldehyde 3-bromo-hexanal. Okay, so hexa is meaning 6 carbons. The aldehyde is on the end, so we've got carbon with our aldehyde, and then carbon 2, 3, 4, 5, 6. Okay, and 1, 2, 3. On the 3, we've got the bromo. Okay, so we've got, okay, and we've got our remaining hydrogens here. Okay, so we've got 3-bromo-hexanal. Now, when we go to reduce an aldehyde, okay, we use hydrogen, and we use a metal catalyst. That might be something like nickel or platinum, palladium, something like that. Okay, now in a reduction of an aldehyde, what we're doing is we're decreasing the number of carbon-oxygen bonds. So that double bonded right there, that carbonyl group, we're going to reduce the number of carbon-oxygen bonds. So we've got 2 carbon-oxygen bonds there. We're going to reduce that to 1 carbon-oxygen bond. Okay, so when we do that, 1, 2, 3, 4, 5, 6. There's the 6 carbons. There's the backbone. Okay, the bromo is still on the 3rd. Now on this aldehyde, okay, we're reducing the carbon-oxygen bonds, so now we only have 1 carbon-oxygen bond. Hydrogen connects there, okay, and then we have hydrogens here in the ring position. So we went from an aldehyde, went through the reduction, and we produced a primary alcohol. Okay, we produced a primary alcohol. Okay, the bromo on the 3rd carbon is still there, but now on this 1st carbon, instead of having that aldehyde, that carbonyl group, we have a hydroxyl group there. We have the alcohol. Okay, so it would be a hexanol now. A hexanol, so it'd be 3-bromo-1-hexanol. So what would be produced? Okay. Now, when we work with a ketone, okay, with a ketone, let's say we have 2-methyl, 3-pentanone. Okay, so let's draw that out. 5 carbons. Okay, so 1, 2, 3, 4, 5 for the pent. Okay, the ketone is on number 3. Okay, on number 2, there's a methyl. Okay, so 2-methyl, 3-pentanone. Okay, we still have all of our hydrogens here. Okay. So now when we do the reduction using hydrogen again, using a metal catalyst, let's use platinum this time. Okay. Our ketones get reduced to secondary alcohols. Okay. So same principle, reducing the number of carbon-oxygen bonds. Okay, so we have our 5-carbon chain. Okay, we still have our methyl, number 2, and now here we have got an OH, an alcohol, see, from the carbonyl to the hydroxyl, hydrogen. Okay, we still have all of our hydrogens here. So now we have the 2-methyl. Okay, that methyl group is still there, but we have the number 3. Instead of having the ketone, we have the alcohol, so it becomes a pentanol. Pentanol, okay, on number 3, and the 2-methyl is still in position.